we felt there was a good idea to quickly show what has changed over the years, and those who attended the opening ceremony had a little bit anticipation on what I'm going to present. This was the first paper treated in 1977, actually, not 78, in Vicenza, with a simple artery and vein connected through a very simple circuit in which there was heparin infusion and reinfusion in the venous line. We used large bore catheters in order to get adequate flow, and in some cases we actually used even fistulas or the so-called Scribner's shunt for vascular access. And in this case, of course, blood lines had to be very, very short in order to minimize resistance and get the best blood flow through the system. Ultrafiltration was produced by the height of the ultrafiltrate column that was providing negative pressure on the filtrate compartment of the filter. At the beginning, very large filters were used, but with such a low blood flow, they were providing high resistance, high filtration fraction, and they were actually making clotting very easily, while specific filters designed for this purpose were provided just afterwards with small surface area and a small priming volume. So a series of these filters have been actually developed mostly in our center. Some of these filters remain only experimental. With the time, we started to use ultrafiltration control systems, whether it was a gravimetric control with a smart clamp or, as in this case, a volumetric control provided also by the indication of a scale. Bob Geronimus in Florida and our group in Vicenza decided to try to circulate dialysate flow countercurrent to filters. He used a low flux dialyzer, starting what was considered the first example of continuous arteriovenous hemodialysis, and we started to do this with high permeable membrane, providing the first description of continuous arteriovenous hemodiafiltration. It seems simple today, but the original filters, as you can see here, were designed with a single ultrafiltrate port, while we had to ask the company to provide the filters with double ports. And this was the first patient in which dialysate was circulated countercurrent to blood simply by gravity. From CAVH, we started to move to vein-venous continuous renal replacement therapy when we started to use blood pumps in the critically ill patient. Today this seems logical, but at that time, actually, using a blood pump in the ICU was not the most simple task, because most of the ICU centers didn't want to have any type of blood pump in the circuit. And you can see here that you have to add the pressure monitoring and bubble traps for safety in the system. We wanted to add many other things: a warmer, ultrafiltration control, drug infusion, manometers, heparin infusion. We ended up at the bedside of the patient with this configuration. And many of these devices were actually not talking to each other, leading to easy error. For this reason, new adoptive technology started to become standard technology with new devices that were mostly provided with a blood pump and the dialysate or ultrafiltered module with reinfusion. And in the third decade, actually, we started with dedicated machine. This was the first machine ever designed for continuous therapies in intensive care. And as you can see here, the pre-assembled lines were actually allowing to simplify blood priming, which seems to be one of the most difficult tasks by ICU nurses as compared to dialysis nurses. Other machines were following with the characteristics that allow to perform mixed hybrid therapies, including SLED or intermittent hemodialysis or daily extended dialysis, with the large screens, large capacity of fluid management, up to 20 liters, and a system to warm dialysate or filtrate. In some cases, monitors to detect blood volume variation could be added to the standard CRRT machine, or specific machines designed to be operated with one single command, the one-button machine as it has been defined in the past, were conceived. Going into detail, we can say that the increase of use of technology, information technology, and software allowed the machines to become somehow tutorials of themselves, allowing the nurses to know step by step what they had to do to prescribe and to deliver correct therapy. And many of these machines have passed to our center. As you can see here, these were the first Prismaflex machine. You can see with different colors compared to the one you're used today, because the serial number of these machines was 001. But we understood very soon that our CRRT machine should be probably platforms rather than machine for kidney disease in order to support organ failure. We know that we can support kidney disease, and today, actually, this is a Ravi-Mehta slide that clearly distinguish what renal replacement therapy and absolute indication represent as compared to renal support therapy, with what are called the relative indications. Concerning the amount of treatment delivered in many years from the original description of Stork and Hinton in Lancet, that a little more dose was resulting in more survival. There was our seminal paper in 2000 showing an increased effect on survival in dose. And after that, Ashita Lulvani, Soudan, Bellomo, and of course others, including Palevsky, have provided somehow data to this graph, allowing to describe that there is a dose-outcome relationship, but the, let's say, cutoff point is somewhere between 20 and 30 milliliters per kilogram per hour. About modalities, more or less, it is clear today that you have to be ready to cross from one to another. This is our semi-intensive care unit, where you can see a continuous therapy and intermittent therapy being delivered side by side at the center. We can provide heart support. One of the things we learned is that you might have hemodynamic instability related to ultrafiltration removal for two reasons. In one case, which is this one, is when blood volume drops because you are removing fluid too fast. Although bioimpedance describe a condition of overhydration, the refilling rate is not fast enough, and you have a drop in blood volume, thus hemodynamic instability shows up. When the patient normalizes hydration status, you still can have hemodynamic instability, but for another reason. The reason is that you can actually remove too much. You can provide extracorporeal lung support by removal of CO2 in conjunction with CRRT. This is a characteristical circuit in which you can do extracorporeal CO2 removal for lung support. Liver support is also provided by different modalities, including CPFA, MARS technology, as in this case, or the Prometheus machine. And many of these technologies have been also used to provide sepsis support. In most cases, studies have been done either trying to increase ultrafiltrate volume or to increase the cutoff of the membrane or to use solvents in combination with therapies. For high volume, we tried to use pulse high volume, to use a very high volume exchange for a few hours during the day. We actually achieved some results in this field. For high cutoff membranes, different membranes can be actually utilized, starting from high flux to high cutoff to protein separation, plasma separation membrane. And this slide was shown in a previous meeting by Rinaldo Bellomo, demonstrating the capability of some membrane to remove significant amount of myoglobin. Of course, there are other modification of membranes like the N69SC surface treatment, where you can actually modify the kind of thrombogenic characteristic of the membrane by simply inducing heparin absorption or simply by modifying the hydrophilic structure of the membrane itself. The interface of the membrane and the interaction with protein also may add important effect on the absorption capacity of the membrane itself, and the interaction with water that is being well described by the recent NV value membrane called HydroLink, where the hydrophilic sites seem to prevail on the hydrophobic site. And this was a study recently presented at the EDTA meeting in London. Also, surface can be modified using vitamin E, and in some cases now we are trying to analyze the effect of this vitamin E modern membrane on the oxidant stress occurring in acute kidney injury patients, especially because in this case you are not releasing antioxidant, but you are simply flowing the blood through a bed of antioxidant substrate. Sorption can be used in combination with dialysis. This was the first use of what today is called cytosorbent. At that time was provided by a company in New Jersey, and then now it has evolved into a more acute associated treatment device today. And sorbents can also be used in conjunction with plasma filtration. When the sorbent is not particularly hemocompatible, you can filter plasma from the blood, circulate through a sorbent, and then return to the blood and eventually dialyze this. And there are today machines that are designed to provide this, let's say, ready to go. The sorption technology has evolved also into specific absorption of substrates like endotoxin, and meta-analyses have shown that there seems to be, both in randomized and non-randomized studies, aspects that favor the use of this sorbent with relative risk reduction and diminished mortality at 28 days in the ICU, including an improvement significant in cardiovascular SOFA score. I think that it is extremely important to consider that all these aspects today are integrated in most recent high technology machines, and we have an enormous amount of devices available, and this is something that should enable us to provide kind of better therapies. My last part of the talk will be on the technology that has evolved to treat pediatric patients. As you probably know, the first baby ever treated in the world with continuous arteriovenous hemofiltration was in Vicenza, starting in 1982, and in 1984 we published in Kidney International the first series of babies treated with these mini filters. Last year in Lancet we reported the case of the first baby ever treated with this new device called Carpe Diem, which is a miniaturized machine for neonates with a very, very low priming volume, very accuracy of the pumps and the scales, so that the neonate can actually safely be treated. Just to mention the operational characteristics, we treated this baby for more than 400 hours of extracorporeal therapy with a blood flow of 9 to 11 milliliters per minute and an ultrafiltration rate in the range of 1 milliliters per minute. So evolution in this field actually occurred also in the last 4 decades. Last but not least, I would like to acknowledge this interesting new device which has been presented in Canada last year. Is called SAM, and here seems to be the fathers of this project, in which you see practically no external circuit or pumps running, but there is a kind of hydraulic circuit inside the device that provides extracorporeal circulation, ultrafiltration, and different treatments. So I think I made you running very much, and it was probably something like 4 minutes or 40 years in 4 minutes, but basically this is to show, especially to young people, that there are 2 statements that I would like to make, and I think I still have the time to do that. One is, When you start reading a paper that begins with, in spite of technological advances, mortality in AKI has not changed, is wrong. Mortality has changed. Also, it has changed more than you expect because we are treating patients that we were not even thinking to treat many, many years ago. The other thing is, although you think that these changes may have occurred for different reasons, part of these changes have certainly occurred because a bunch of people and scientists and members of the industry with a fantastic alliance with the academic world has allowed to improve the safety, the quality of the treatment, and the potential number of treatments that can actually be performed with the new technologies. Hopefully, we are going towards the future, less thrombogenic surface area and membranes, more safe machine, easy to use interface, but one of the future challenges, in my view, will be education and training. We need to make people aware of how the machine works and what is the best way to use that. I had the chance to review several complaints of malfunction of machines for 2 or 3 companies. I can tell you 98% of the complaints were not due to malfunction of the machine. It was a misuse of the machine. So I think that we have to learn how to use the technology and to value the effort that has been made to improve the quality of technology. Thank you very much.